guys, let's go through these just to see how you did. Are you ready? Do you need a minute?
Yes.
Like one more minute?
Yes.
Okay, one more minute. Then we'll go through them. Yes. Did you guys agree? You and Aiden, or? Okay. Maybe not. Well, I've asked for donations. Haven't really gotten many from this group.
Just one around.
Is the x plus 2 the second?
It is, yes. X plus 2 squared. It's a really small 2. All right, back row, we ready now?
Yes.
Yes, okay. Okay, guys, number 1. I hope you recognize that's a polynomial, not a rational function. Okay, and what do we have to start with on that? The p over q, because I didn't give you any... That's not what I need. Interesting. I didn't give you any factors or solutions or anything like that. So you want to start with your p over q list, which ended up being 1, 2, 4, 8, 1/3, 2/3, 4/3, 8/3. What was one that worked, guys? 2? I think 2 worked, right? Okay, so then I have 3x squared plus 13x plus 4. Guys, I guarantee you on Friday you will have to factor, okay? It's never going away. Make sure you can do it. So this is going to factor into what? 3x plus 1, x plus 4? And guys, what's the other factor that I need to consider when I'm graphing? X minus 2. Okay, don't forget that, guys. So this is a polynomial, so I know I have x-intercepts at -4, -1/3, and 2. What's my y-intercept? -8. Okay, what's the degree of this function? 3. So what are the ends doing? Yeah, 1 up, 1 down. And do I have any multiplicity to worry about? No. So it's going to just go through my points, something like that. How'd we do? Okay. Okay, so that's back to skill 1. You do have that reassessment Friday. You will have to graph a polynomial on your reassessment. All right, second one, this is a rational function, so we want to go ahead and factor to begin with. Let's see, maybe 2x plus 1, x minus 3, 1x minus 3x plus 5. So guys, right away, what do we see that we have? Whole. Okay, coordinates of the whole. 3, 7, 8. Okay. Then from here, remember you're doing everything with the reduced fraction. What's the vertical asymptote? Okay, and please, please, please write it as an equation. That is always x equals -5. Okay. All right, top heavy, bottom heavy are equal. So that makes a horizontal asymptote. What is it? Y equals 2. Good, make it an equation. X-intercept. Yep. And write that as an ordered pair. So -1/2, 0. And then the y-intercept, what would that be? 0, 1/5. I gave you just lovely numbers to graph, didn't I? All right, so 3, 7, 8. You get a whole. Vertical asymptote at -5. I'm definitely not giving myself enough room. -1/2, 0, 1/5. Okay, so the right side of the graph, we've got all sorts of points. Goes through your hole over here. We're good with that, right? Okay, you know where the left side is going to be, but find that one additional point for me. What would you plug in? -6. What do we get? 11, right? Yeah, so somewhere up here, I am going to run right into all the work I just did. You'll have a little more space than I have up here on your assessment, okay? All right, how do we do on 2? Okay, good. Questions? If it didn't go well, anything that we're stuck on? Okay. Yeah.
What's the extra point?
That's a lovely number, isn't it? It's supposed to be 6/11. I don't know what I wrote. How about that? Okay. Questions before we look at 3? All right, again on 3, we need to factor. What does our numerator factor into? -4. Okay, good. All right, so is there a whole this time? No. Is there a vertical asymptote?
Yes.
Yes, and how do we say that?
X equals
Good, x equals -2. Top heavy, bottom heavy are equal. Okay, so what does that make? And how do I find that? Yes, I'm going to do -2. Okay, do I care about the remainder?
No.
Okay. And I'm going to stop there. So your slant asymptote is the equation y equals 2x minus 9. All right, x-intercepts. You have 2 of them.
1, 0, and
Good. By 3, do you mean 3 halves?
oh yeah, 3 halves.
Okay. I know I'm writing small, guys. Y-intercept? 0, -6. Good. All right, let's start with all of that. I need more tick marks. This one was way off your graph. So y-intercept is down here at -6. Multiple x-intercepts. Vertical asymptote at -2. Horizontal asymptote was, or I'm sorry, the slant asymptote, when it's 2x minus 9, that means start at the y-intercept of -9 and then count your slope of 2/1 from there. So it's down here, something. That's not super accurate, but you get the idea. Slant asymptote. So this piece is easy. We've got our points. Follow your asymptotes. Am I right that you guys know where the other piece is going to go? Like, we know it's going to be down here, right? What point do you want to plug in for me, though? -3, what do we get?
Negative 21.
Okay, wonderful. That's exactly where -3, -21 is. Yep.
On the test, if you like, you have to get the sign, the line of the sign has to be completely like perfectly correct.
So you'll have like an actual grid to graph on. So, you know, I would expect like some accuracy, but I'm not like, you know, it doesn't have to be perfect. But if you're like, oh, I started here and then my line went like this way, I'd be like, no, that's not the right message. Okay, we all right with number 3? All right, the last two are both inequalities. It's a skill 1 inequality and a skill 2 inequality. Same idea with the number line, just different work leading up to it. So number 4, you have to bring that 2 over. I need a common denominator. So I have 3x minus 2, and then just be careful distributing here. It's going to be minus 2x minus 2 all over x plus 1. So I get x minus 2 over x plus 1.
X minus 4.
4. Yep, that's 4. All right, are we okay there? We're doing okay with common denominators? Yes, okay. So what are the 2 critical numbers on my number line?
-1 is 4.
Okay. I can test 0, it's in the middle. I get a negative over a positive, so that section is negative, okay. Will it alternate?
Yes.
Yes. All right, greater than or equal to 0, right? That's what I'm looking for. So I know the positive parts. Am I including the -1 and the 4? Just the 4, yeah. Not the -1, okay. Why can't I include the -1? It's a denominator. Yeah, what would it make in the denominator if I included -1? 0. We don't want 0 in the denominator. Okay, so any of those critical numbers that came from your denominator, automatically right from the start, they are not included in your answer. Okay. All right, questions on 4? 5. We can just jump right to the number line on this one. You have 4 critical numbers this time. We've got -5, -2, 1, 3. Okay. So I'm going to test 0. Think about where 0 is on the number line, and then I plug it in. 0 minus 1, -1, cubed, still negative. 0 plus 5 is positive. Plus 2 squared, still positive, and then -3, negative. So, what is that section? Positive. Okay, guys, then it's all about the multiplicity. I'm going to work my way to the right first. Does the 1 have multiplicity?
Oh, yes.
Yes. Is it even multiplicity?
No.
No. So what does that mean is going to happen on the other side of 1? Yeah, so that'll be negative. Does the 3 have multiplicity? No. So what is it on the other side?
Positive.
Okay, now working our way back. Does the -2 have multiplicity?
Yes.
Is it even?
Yes.
Okay, so what's happening?
Positive.
All right. -5, what's happening on the other side of that? Okay. All right, now guys, this one is a little tricky. I am asking you for less than or equal to 0. So I know I want the negative parts. Just those 2. I don't have any fractions, so I can go ahead and include the 1 and the 3 and the -5. What else do I need to include? No? Yeah, -2. So your answer to this is negative infinity to negative 5 with a bracket, then just negative 2, the point on its own, and then 1 to 3. What? So it says less than or equal to 0. What happens at negative 2? It's equal to 0, so you got to include it. Okay. Tricky, right? Those points, negative 5, negative 2, 1, and 3, that is where this polynomial equals 0. Okay, so when it says less than or equal to 0, no fractions involved, you have to include all of those points. Okay? Normally, the endpoints get picked up by whatever our inequality is, but this time there was one just floating. All right, questions? Anything at all? Okay, we're doing the practice quiz next. We're just practicing class today, guys. Okay. So treat it as if it's a quiz to start with, put your notes and stuff away, try it on your own. And then if you get stuck, check on your notes. And guys, there is one question on the back of your worksheet, so plenty of room to do that one on the back. I don't know what happened with it's back there. It looks lonely. got another minute here, then we'll go through it together. And actually, guys, before we go through it together, talk with your neighbor, compare your quizzes, see how you did. Do you agree? Do you disagree? Talk with someone around you. And Carrie, you can check with Sydney if you want behind you. She doesn't have a neighbor again today. All right, guys, let's go through this, make sure we've got it all figured out here. So the first one, I gave you a graph, and then I asked you for specific things from that graph, kind of working backwards, not just making the graph and listing it all out. Can you tell me what's happening? So guys, if I'm talking about a factor that's in both the numerator and denominator, which like feature of the graph is that we're talking about? Yes, the whole. Good. So what did you guys say for the factor? Yeah, can I count 1, 2, 3? Yep, x minus 5. Good. Okay, a factor only in the numerator. X minus 1 or x minus 7. That is talking about the x-intercept. If it's only in the numerator, we know numerator equaling 0 is the x-intercept. No, one or the other. I have all or in here. Doesn't matter. Just make sure you don't put one that's wrong. No. It says name a factor. So. All right, name a factor only in the denominator. You've got two options here as well. X plus 2 or
X minus 2.
Yeah, this is talking about your vertical asymptote. And then the quotient of the leading coefficients. Yeah, you can write 3 over 1. I would also just take 3. That's the horizontal asymptote. There are 3 tick marks there. It's not the easiest graph to read, but. Guys, if you understand this and could answer these questions, then you have a very good grasp on what's going on with rational graphs. Okay? So, anybody questions on any part of this? Yeah?
What if in B you just wrote 3?
That's okay. Yep. Okay. Now we're going to actually graph one. What do you see that we have right away?
A hole.
A hole. Okay. What is the coordinates of that hole?
2, negative 3.
2, negative 3. Good. Do we have a vertical asymptote?
Yes, yes.
And how do we write that?
X 3.
Good. Horizontal asymptote this time. What is it? Good. X-intercept. Negative 1, 0. Y-intercept. Okay, let's plot this. 2, negative 3. Okay, so we're good on the left side of the graph. What are you doing for your extra point this time?
4.
4, and what do you get with 4? 5. All right, how do we do? Good. Excellent. We're getting good at graphing rationals. Yay. All right, any questions before I switch to the back? Yeah. Oh, yeah, I didn't answer the domain part. Okay, domain is your x values. So you start on the left side of your graph and you just work your way across, leaving out any value that's not included in your graph. We have 2 x values not included in this graph. What are they?
Negative 2 and 3.
2 and 3. So your domain is negative infinity to 2, 2 to 3, 3 to infinity. Parentheses on all of those because we're not including them. Okay. Questions? All right. Oh, see people writing. Give me just a second here. Okay, let's look at the back. We need to bring that 3 over right away. And then I have the common denominator of x minus 4. You can simplify that numerator. Are we okay with getting to that point of 10 over x minus 4? Okay. Did it throw you guys off that there wasn't an x in the numerator? It just means you only have one critical number. What is it? 4. So it actually makes it simpler, guys. There's nothing that would make your numerator equal 0, so there's no critical number coming from the numerator this time. So I test 0. I get positive over negative, which is negative. Will it alternate? Yep. less than or equal to 0, so I know I'm starting at negative infinity and coming to 4. Will I include the 4 or not? No. Why? Yeah, it's in the denominator. We don't want it. Okay. Questions? Not too bad on the practice quiz? Yeah.
Will the test have like 3 questions too?
You can have 2, 4, 3. It's not real long. Like it's 1 page. Okay. Oh, sure. Guys, I'm going to pass out a review worksheet. It's not real long on the review. And then there is a Delta Math review for you guys as well. Makes sense. So if you look at the graph, you see how the whole and the vertical axis like go to the x values that we're not using. So that's what your domain is saying. If you're starting at negative infinity, we're going to skip over 2 because there's a hole. And your graphic says that we choose 3, but then you have to jump over 3 because there's an s to go. And then it continues from 3. Because that's what the whole vertical axis is. Because you're telling me like what x values basically exist on the graph. Does not exist on your graph. So guys, things to use to review. We've obviously got the worksheet I just handed you and Delta Math. Don't forget to look back over your Skill 1 stuff. Okay, the Skill 1 reassessment will replace your Skill 1 grade that you already got. Whatever it is, it replaces it. Better, worse. You will get another shot at it if you need it on the cumulative, but understand that that's what's happening with the reassessment, okay? So use your old assessments, your old review. You've got your old Delta Math, your notes, your warm-ups. All of those things are good. Good things to review going into your assessment on Friday. If you have questions over that, let me know. Otherwise, you've got some time to work.